Howdy, everyone. Thank you so much for letting me work remotely today. And I'm going to do something a little different, I think, than the previous talks and look at ethics in disaster robotics and what that might mean for both disaster robotics and robotics as a whole. So let's go to the next slide, number 2. Because, you know, there's ethics, but what I'm really interested in is professional ethics and the things that are contingent on us as engineers and developers and technologists to what do we do to build this technology and make sure it's used correctly. Next slide. So if we look at some of the definitions out of moral machines, that machine ethics, operational morality, which is about basically the accountability and the responsibility of us that are building these tools. We have functional morality, which is interesting because it's either systems that are autonomous, not necessarily fully intelligent, but like the self-driving car, they're making decisions that need to be cognizant of impact. But there's another one that the disasters fall into, certainly, is ethical sensitivity, regardless of whether they're autonomous, regardless of whether they're being teleoperated. There's things that just are called, like medical robots and rescue robots. There's some aspect of them that falls into ethics. And then we have full moral agency. And next slide, the fourth. And so operational and functional morality, the robot really isn't that smart. It's really directly it impacts the way we program it, design a human-robot interface, the way we market it, the way we embed it into a system. And therefore, the designer is responsible. And so these two types of morality is where professional ethics come in. Next slide. So I'm going to give you some examples, 2 examples of operational morality that I've run across, and then 2 of functional morality, and talk about those. So going to slide 6. So one example of operational morality was the Fukushima Daiichi response. And we can play that video, which you can see that Honeywell T-Hawk was used for radiological surveys and inspections of structures for the first 6 months of the disaster. And one of the big selling points for the T-Hawk was, it's fully flight and autonomous navigation. So next slide, to slide 7. Well, they didn't use any of that autonomy. So here you have this trained crew. These are the top instructors. They have trained in chemical biological incident response training. They're all suited up. Here they are, and the first thing they do is turn off the autonomy because they couldn't trust it, because they couldn't see what was going on. It turns out that the way that the user interface was set up is that you couldn't see any of the status dials. So here you are taking a robot into a totally new situation. You're flying into a heavily radiated place. You have no idea if the radiation is going to knock out the wireless communication, it's going to knock out any type of your control computers on board, all of that. And of course, even though there's pretty much nobody left there, a crash is not a good thing. You could actually crash into the reactor or the pod that was holding the rod to make things worse. Well, because they couldn't tell, they couldn't be sure if anything was going wrong while it was flying in high winds, they wanted to manually control. Then they would know that if it went left, it was because they had reached over, and moved to the left versus the system. So that's a bad design, right? Let's go to slide 8, Hurricane Harvey. So in Hurricane Harvey, we have a DJI Matrice 600 with a high-resolution camera. It's a fantastic $30,000, autonomous flight. You pop it up, it's not going to follow the sky. You can give it waypoints to go to. Really great. Next slide, slide 9. Well, there in the middle of Hurricane Harvey, we did a forced update. But the forced update had a bug. So the operator lost control of it. The operator was me. I was able to regain control, and then we didn't use that UAV for the rest of the disaster. I mean, think that. First off, now we don't trust it. We can't revert back to the previous version. Oh, even better, we don't have time to do that, to take an hour to revert that back. I needed to sleep. We had other ways to get the data, not as good, but this was just unreasonable. Next slide. So the operational morality takeaways that we saw the lack of visibility and transparency. As designers, we didn't see that there's a tendency to assume, that things are like computer software. You can do an undo function. You got to, back up. Only problem is physically situated agents, robots can't do that. I mean, we move an arm through a window, we can pull it back, but that window doesn't just zip back into place, right? And also the awareness that operators, no matter how autonomous the system is, operators will be responsible for it and for the consequences. And if anything goes wrong, and if they don't trust it, it's not going to be used again. And to remember, particularly disaster robots, but how many other things like medical robots, you don't have time to diagnose what's going wrong or, and reinstall or do a test flight, So it's really important, and I think that's something that we've lost a little bit in the engineering education side. It's really important to understand the system. It's great to design widgets and new wonderful algorithms, but we need to understand the system. Next slide. And then understanding the system includes the system, the bigger set of stakeholders. And that gets us into functional morality, where we're talking particularly about the ethical sensitivities. What are these users? What is their enterprise that they're working in? Next slide to slide 12. So I'm going to use the Blanco River flash flood for the two examples, kind of merging that there are multiple things that went wrong. So during Memorial Day, the evening of Memorial Day, the Blanco River had a flash flood at midnight. Everybody in Texas loves to camp, and nobody went to high enough ground, even though there was a reverse 911, all of that. So 21 people were missing, presumed over a stretch of about 5 miles of curvy river. Floodplain is a mess. It's like all these nasty mesquite trees, and a large number of volunteers all show up with drones, so they're going to help collect data. And so when you do this, you get this high resolution images. You don't use video. You have to do that. Well, so first off, now this is a type of morality, right? Is that some group said, I've got a drone, I'm going to fly it no matter what the flight restrictions are, the fact that there are helicopters flying it low. And we watched 2 instances where UAV and manned helicopter almost collided. And on the ground, I think the pilot of one of the helicopters actually hunted down the drone person to explain how dangerous that was. But that wasn't the big problem. Watch what happened. So now we're on slide 14. So DJI, as the manufacturer, and other app manufacturers pushed out geofencing to prevent that from happening again. Oh, if it's a TFR, you can't fly, and then if you're going to fly under the TFR, you have to present credentials and request exemption, that you're actually allowed to fly under that TFR and get your exemption. Next slide. Except they wanted 2 business days. I'm glad disasters don't happen on weekends. 2 business days, and you've got the time change to China. Okay, so that's unworkable. How do you do that during a disaster where your mortality rate is that they don't find you within 52 hours? Yeah, you're pretty much dead. And so then at Harvey, they conveniently just totally turned off the geofencing. They said it was due to unrelated server problems. Personally, I believe it was due to them being inundated with requests and not wanting to try to figure out who had jurisdiction. So how is that responsible? Okay. And then keeping on, another thing is that this is not a manufacturer's problem or responsibility, but interesting to know that going back to the Blanco River, people are posting to Facebook saying, hey, here's 400 high-resolution images. See if you can find the dead bodies in this picture. Wow, that's violating personal identification and privacy rights. And I mean, how uncool is that to say, oh, look, that's your father, that's your daughter. They're on Facebook. Yep, dead bodies. So that needs to be cordoned off. But that's something to just keep in mind. Let's go to slide 17. Well, one thing, the reason why those people did it was because you get a data avalanche, which gets a wonderful, too many images to look at. A data fly, you're quickly looking at 800 images, which is about 22 hours for a person who's trained to look through those images. Well, wasn't that a great idea to start using computer vision? Absolutely. And so we were able to put together some programs that were able to process those images in 90 minutes on a regular laptop, and we created a toolkit for the responders, and that's all good. And here's where we went wrong. So the second example of functional morality is that we basically overpromised. So we went to a wilderness search and rescue exercise as part of a team report. We said, okay, great, we'll go do this, and we'll go find the people using our new spiffy software, machine learning software. And it didn't work. It did not work. And if that had been a real search and rescue exercise, we would have wasted a lot of valuable time and resources on something that was going to work. And so that becomes, let's go to slide 19, really important. So the algorithm could not find Aaron, who's right here in the middle of this picture. If you look, you see his blue, he's laying down. No fool, he actually brought a mat to lay down on. Let's go to slide 20. Well, the problem is that different seasons, different types of vegetation just threw off the algorithm, and that is a problem. Transfer of domains is a real problem in machine learning for computer vision. But the problem is over-promoting and not being aware of it, okay? Telling the responders what it was. So if we're on slide 21, the takeaways are, when you build these systems and think about the robots, there may be larger ethical issues than just the algorithm, what the software, or even what the agent's doing. It's kind of that bigger picture. And what works for one ethically situation may not work for another. And it's not responsible to ignore that. And so the possible, let's go to slide 22. And so the possible solutions are, first off, we just shouldn't be working in bubbles. I mean, we just need to be better about thinking about these big pictures. And certainly, me too. And I think also when we're thinking about how we approach ethically sensitive applications, we need to be realistic and responsible. If we don't know what the false positive, false negative rate is, or the limitations of the algorithm are, then we probably don't have a sufficiently robust or well understood algorithm to take. Are we just going to write more robust code, or maybe just quit saying everything solves all the problems in the world? Okay, slide 23. So just to kind of pull back a bit. So, for these examples, is this really a big deal? And I think maybe it is. I think that the operational morality failings aren't unique to disaster robotics. They seem to be a failure of either teaching or applying engineering design process. And as an academic who teaches capstone, I've really tried to emphasize that and have been really motivated to emphasize this need for reliability, visibility, and how to increase trust. And I think the functional morality failing seem to be a failure to really acknowledge ethically sensitive situations. We just have to do better at this. I mean, we have to do more to make sure that we're not over-representing, that the algorithms are more robust, that these things and it's not the same as rating a music streaming app. Well, if it crashes or it doesn't do exactly right, whatever. These are in fact important, and they may seem small distinctions, but they could be huge in real life. And so let's go to slide 24. So, the intent to do good with robots doesn't mean the robots did the most or best good. And I think that's one of the things I'm so excited about this workshop and really appreciate Raj and his team, the work in putting this together, especially Ivan, who's the only reason I'm able to give his presentation. Ivan's hard work. But this idea, we all want to do good with robots, and we all are doing good things with it, but we've got room to do even better. and I look forward to being part of that future and working with you. Thank you.
In the interest of time, we're probably going to do one or two questions, and Ivan is going to have to repeat it, so keep it pretty short.
So she mentioned that as an educator, she's trying to bring this into engineering education. Can she share how she's doing that?
So for me, as being able to teach senior capstone design, is that I try to expose my students to the idea of the larger enterprise as stakeholder, working directly with customers, but also ways of trying to map out what the bigger impacts are. Also, we talk about ethics and try to get across to them that this idea of operational morality and functional morality, that they may be working on ethically sensitive. One of the things I think that we've lost in the computer science community is thanks to, quite frankly, people like Larry Ellison and Oracle, where get the code out, who cares if it has bugs, as long as we get market share, then we'll come back and clean it up. And I'm seeing that startup mentality kind of permeate our undergraduates and even graduate students, sort of approach the project. And it's like, oh, we'll just get close enough and that'll be fine, and then we'll fix it. And there's just sometimes when that doesn't work, and also focusing on an algorithm doesn't mean it works for the big picture.
Okay, one last question before we go for lunch. Okay, let's thank Robin.